Hello mga ka-wisdom! Welcome to Wisdom is Power channel. Kung bago ka pa lang sa channel na ito, huwag kalimutang mag-subscribe, i-like, mag-comment, at i-share ang video ito. Click mo na rin ang notification bell to receive more wisdom videos na katulad nito. Salamat! Today we're going to discuss about magnetic fields and forces. So this is the part 1 of our lesson. So magnetism. So we all know that magnets have two poles, the North Pole and the South Pole. And we know that like poles repel and unlike poles attract. So pag pinagsama natin yung parehong North or parehong South ng ating magnet bar, magre-repel sila. Pero pag pinagsama natin yung opposite pole, halimbawa isang North, isang South, then there will be an attraction force between these two poles. Magnets create a magnetic field around them. So makikita natin may mga magnetic field lines tayo. So magnetic fields can be visualized with field lines. It start at North Pole and end at South Pole. So yung magnetic field lines natin, manggagaling sa North, ang direction niya papunta siyang South Pole. So the more lines in one area means stronger field. So a magnetic field which is represented with the symbol B. So yung B natin ay ginagamit natin para ma-represent yung ating magnetic field. It can be visualized using small iron filings sprinkled onto a smooth surface. So sa mga previous experiments natin, kapag pinagtapat natin yung south at north, then nilagyan natin siya ng mga iron filings natin, then makikita natin yung magnetic field around these two bar magnets. So Earth, like many planets, produces its own magnetic field. In many respects, Earth's magnetic field is like that of a giant bar magnet as illustrated in the figure. So makikita natin yung ating Earth para siyang isang merong malaking magnet, no? So ganun pa rin yung ating magnetic field of lines coming from north, ang direction niya ay papunta siyang south. So magnetic field is measured in terms of a unit called the Tesla. So para ma-measure natin kung gaano kalakas yung ating magnetic field, ginagamitan natin siya ng unit na Tesla. It is named after engineer Nikola Tesla. The magnetic field at the surface of Earth is roughly 5 times 10 to the negative 5 Tesla. So ganun ang magnetic field ng ating Earth. So that is 5 times 10 to the negative 5 Tesla. So another commonly used unit for magnetism is the Gauss, or the symbol G, which is defined as 1 Gauss is equals to 10 raised to negative 4 Tesla. So the magnitude of a magnetic field, when an electric current flows through a wire, it creates a magnetic field around it. So yung ating wire, so kapag dumadalo yung ating electric current doon sa wire natin, meron tayong invisible magnetic field doon sa wire na nadidevelop, no? So the strength of magnetic field is directly proportional to the magnitude of current and inversely proportional to the distance of the point from the conductor. So halimbawa, meron tayong wire dito at yung ating current ay dun sa upward direction, merong nakikreate na magnetic field around dun sa ating wire. So the direction of the magnetic field in relation to the direction of electric current through a straight conductor can be depicted by using the right-hand thumb rule. So kung hahawakan natin yung wire natin, then yung ating thumb, yun yung direction ng current ng wire. Then yung natitira nating mga daliri, no? So that is the direction ng ating magnetic field. So the equation para malaman natin yung strength ng magnetic field or the magnitude of the magnetic field that is equals to mu multiplied by I all over 2 pi times R. So, ito yung magsasabing equation na ang strength ng ating magnetic field is directly proportional to the current. So, ibig sabihin, habang tumataas yung current natin, lumalaki din yung magnetic field natin, yung strength ng ating magnetic field. And it is inversely proportional to the distance of the point from the conductor. Kung lumalayo naman tayo dun sa wire or any object na lumalayo dun sa wire, then humihina naman ang kanyang magnetic field. So kung mas malapit yung object sa wire, mas nararanasan niya o na-experience niya yung mas mataas na magnetic field or strength of the magnetic field. So yung mga equation natin yan, the B refers to the magnetic field magnitude or the strength of the magnetic field. It is measured in Tesla. Yung ating Greek letter mu, it refers to the permeability of free space. Okay? Ito ay constant value. So every time na ma-encounter natin yung permeability of free space, that is equals to 4 pi times 10 to the negative 7 Tesla meter per ampere. Or that is simply 12.57 times 10 to the negative 7. Yung I natin, that is refers to the electric current in amperes, and R is the distance ng object dun sa ating wire. Ang unit natin is in meters. So let's have a practice problem. Number 1, so find the magnitude of the magnetic field that is 100 millimeter away from a wire carrying a 3 ampere current. So, meron tayong certain object, then meron din tayong wire. So, yung object natin, malayo sa wire na may nagpo-flow na 3 amperes. So, ang layo ng object natin sa ating wire is 100 millimeter ang layo niya, and yung wire natin merong 3 ampere current flowing. So, we are asked to find the strength or the magnitude of our magnetic field. So, using our equation, B is equals to mu multiplied by I all over 2 pi R. So, isa-substitute lang natin yung mga value. Yung ating mu, which is the permeability of free space. Ang constant value natin dyan is 4 pi times 10 to the negative 7 multiplied by the 3 amperes all over 2 pi times 100 millimeter or simply 0.1 meters. If we're going to convert the 100 millimeter, that will be equals to 0.1 meter. So remember, ang standard unit natin for distance is meter. So, kinonvert natin yung 100 millimeter into 0.1 meter. So, our magnetic field or the strength of our magnetic field is equals to 6 micro Tesla. So, let us assume na inilayo natin yung object dun sa ating wire. Sabihin natin, nilayo natin siya sa 10 meters dun sa wire. So, let us see kung ano ang mangyayari sa ating magnetic field. So, kung ilalayo natin siya, so that is 4 pi times 10 to the negative 7, the same pa rin yung current dun sa wire, then 2 pi, tapos yung distance natin, ginawa na natin 10. Inilayo natin yung ating object dun sa ating wire. So, the magnetic field will become 60 nano Tesla. So, masyado na siyang maliit compare kung mas malapit yung object natin doon sa ating wire na nagpo-produce ng magnetic field. So, mahina na, no? So, problem number 2, assume that the magnitude of a magnetic field 2 meters away from a wire is 10 nano Tesla. What will be the electric current flowing in the wire? So, again, the distance ng ating object dun sa ating conductor o sa ating wire is 2 meters. At yung wire natin na yon ay nagkikreate ng magnetic field ng strength is 10 nano Tesla. So we are asked to solve for the current flowing in the wire. So using again our equation, then konting manipulation lang to solve for the value of I, it will arrive to 2 pi R multiplied by the magnetic field all over the permeability of free space. Then isa-substitute lang natin yung mga values given, that is 2 pi times 2, which is the distance, multiplied by the magnetic field of 10 times 10 to the negative 9, that is equivalent to nanotesla, all over the value of the permeability of free space, which is 4 pi times 10 to the negative 7, and we will get the current as equal to 100 milliampere. So magnetic force of a moving charge in a magnetic field. So all magnetism is caused by current. When we say current, it is the flow of charge. Magnetic field exert forces on a moving charges. This force is called the Lorentz force. The magnitude of the magnetic force F on a charge Q moving at a speed V in a magnetic field of strength B is given by F is equals to Q multiplied by V multiplied by B, then sine theta. So this will be the equation of the force or the magnetic force of a moving charge in a magnetic field, where F is the magnetic force in terms of newtons, and Q is our charge in coulombs, and V is the velocity of the charge measured in meter per second, and B is the magnetic field in Tesla, and the theta is the angle between the direction of the velocity and the magnetic field. So let's have practice problem. Number 1, an object accumulates an excess charge of 2 times 10 to the negative 5 coulomb. Determine the magnetic force on the object when passing at 240 meter per second perpendicular to a 50 microtesla magnetic field. So let's have the following given. The charge is 2 times 10 to the negative 5 coulomb. The velocity or the speed of the charge is 240 meter per second. The magnetic field strength is equals to 50 microtesla. And the angle between the velocity and this magnetic field is perpendicular. So it means that the theta is equals to 90 degrees. And we are asked to solve for the magnetic force experiencing by this charge, by the charge. The solution is using our equation for magnetic force of a moving charge in a magnetic field. Then simply we just plug in all the values given. Then we will get force is equals to 240 nanonewton. So for problem number 2, a proton moves with a speed of 2 times 10 to the 6 meter per second at an angle of 30 degrees with the direction of a 300 millitesla magnetic field. Determine the magnitude of the magnetic force on the proton. So the following given, so the charge of a proton is constant, which is equals to 1.6 times 10 to the negative 19 coulomb. And the velocity of the charge is 2 times 10 to the raised to the 6th power meter per second. And the strength of the magnetic field is 300 millitesla. And the angle between the velocity and the magnetic field is 30 degrees. And we are asked to solve for the magnetic force experiencing by the proton. So using our equation and substitute all the values given, that is 1.6 times 10 to the negative 19, the value of the proton charge, multiplied by 2 times 10 raised to the 6th power, multiplied by 0.3 Tesla, multiplied by sine 30 degrees, and we will get 4.8 times 10 to the negative 14 Newton. So this is the force experiencing by the charged proton. Problem number 3, an electron experiences a force of 3.5 times 10 to the negative 15 Newton when moving at an angle of 37 degrees with the direction of magnetic field of 2.5 times 10 to the negative 3 Tesla. So how fast was the electron? So again, for the value of electron, it will be the same value as in proton, or the charge of proton, which is equals to 1.6 times 10 to the negative 19 coulomb. And the force experiencing by this electron is 3.5 times 10 to the negative 15 Newton. And the strength of the magnetic field is equals to 2.5 times 10 to the negative 3 Tesla. And the angle between the velocity and the magnetic field is equals to 37 degrees. So we are asked to solve for the velocity. So using our equation again, then a little manipulation to get the value of the velocity. So that will be equals to force all over Q multiplied by the magnetic field, then multiplied by the sine theta. Then we're going to plug in all the values. That is equals to 3.5 times 10 to the negative 15 all over 1.6 times 10 to the negative 19 multiplied by 2.5 times 10 to the negative 3 multiplied by sine 37 degrees. And we will get the velocity is equals to 14.54 times 10 raised to the 6th power meter per second. So let's discuss also the magnetic force on a current carrying conductor. The force on a conductor carrying current I in a magnetic field with flux density B is defined by the equation F is equals to B multiplied by I multiplied by L multiplied by sine theta, or simply BIL sine theta, where F is the magnetic force on the current carrying conductor expressed in Newton, and B is the magnetic flux density or the strength of our magnetic field in Tesla, and I is the current, the unit is ampere, and the length of the conductor in the field is in meters, and theta is the angle between the conductor and the external flux line expressed in degrees. So let's have another practice problem. So problem number 1, calculate the force on a 50 centimeter wire carrying a 20 ampere current perpendicular to a uniform magnetic field of 1.5 micro Tesla. So let us write the given first. The length is equals to 50 centimeter. I'm sorry, this is 50 centimeter. And current is 20 amperes. The magnetic field is 1.5 micro Tesla. So the value of our magnetic field is 1.5 micro Tesla. And the theta is, since this is perpendicular, we will use 90 degrees angle. And we are asked to solve for the magnetic force. So using our equation F is equals to BIL sine theta, we will just plug in all the given. That is 1.5 times 10 to the negative 6 multiplied by 20 amperes multiplied by 0.5 meters length of the wire and the sine 90 degrees, and we will get 15 micro Newton for the magnetic force. For problem number 2, a 20-meter wire carrying a current of 5 amperes experiences a magnetic force of 8 Newton. So what is the angle between the wire and the 2 Tesla field? So let us write all the given. The length is 50 centimeter. I mean, the wire should be 20 meters. Sorry, but the given is 20 meters. And I is 5 amperes. I forgot to change the given, but this current is 5 amperes based from our given problem. And the Tesla is, and the magnetic field is equals to 2 Tesla, and the magnetic force is 8 Newton. So we are asked to solve for the angle between the wire and the 2 Tesla field. So using our equation, so counting manipulation lang to get the value of sine theta, that will be equals to F all over BIL. Then substituting our value, the force is given, this is 72 newtons, no? Not 8 Newton. Sorry. But the given is 72 Newton, and the magnetic field is still 2 Tesla, and the current is 5 amperes, and the wire is 20 meters. No, the length of the wire is 20 meters. Okay, so the angle between the wire and the two Tesla field is equals to 21.1 degrees for the value of the angle. So that's all mga ka-wisdom. So again, kung bago ka pa lang sa channel ito, huwag kalimutang mag-subscribe, i-like, comment at share ang video ito. Click mo na rin ang notification bell to receive more wisdom videos na katulad nito. So again, thank you at kita-kits sa next wisdom video.